So now we are going over 10.4, which is factoring second degree polynomials. So what we did in 10.3 is we were pulling out single monomials. Now we will be pulling polynomials out of polynomials. And we know we can do that when we have a polynomial of the second degree. So they give us x squared plus x plus 17 from the very beginning. So because this is to the second degree, we know that it's going to equal x plus something times x plus something else. So if you remember back to when we were multiplying polynomials together, is if I take, let's say, x plus 2 and multiply it by x plus 3, right? I'm going to multiply this x here and here, and then this 2 is going to multiply here and then here, using just the distribution rule. So what this is going to look like is it's going to look like x squared, right? Distribute x here, and then distributing this x to the 3, so plus 3 times x, right? And then I take the 2 and I start distributing it. So plus 2 times x and plus 2 times 3, which is 6, right? And you see here that I have like terms, so I can actually simplify this. Plus 5x plus 6, right? So I have a second degree here, right there, which means that I came from two different polynomials. So now we're working with going backwards. So we start with one polynomial and we're trying to factor it into two polynomials. So in this case, we're going to look here, and unfortunately 17 is a prime number, right? So the only multiples of 17 are 1 and 17, which means that there's a 1 here and a 17 here, or they are switched back and forth. But if I do 1 times x and 17 times x, I cannot add or subtract that to just get 1x. So this is currently not possible. But let's look at something that is possible. Let's look at x squared plus 8x plus 7. So again, we want to set it, you see that this is a second degree, right? So we know it's going to be x plus something times x plus something else. So the strategy here is to look at this last number. You know, this last number is a multiple of some other number. It's kind of like doing this is basically like doing the division of polynomials. You can kind of think of it as in the box system, right? If I have a box here, I'm going to have x and then something here and x. So this is going to start off with x squared. Let's put a 7 down here. So you can use the box method if you'd like. You don't have to if you don't want to. But we're starting with this number here. So we know that 7 can equal 1 times 7 and nothing else, right? This is the only other way we can write 7. So that means 7, we can have a 7 here and a 1 here, because 1 times 7 equals 7, which means that this is going to be 1x, because 1 times x, and then 7 times x, so 7x, right? Which means this would work, because we'll write this box as 8x, 7x plus 1x equals 8x plus 7, which is our polynomial here, which means that the 7 goes here and the 1 goes here. So that's kind of like, that's a lot of steps that we're going through. Let me do another problem. Let's look at problem 2. Factoring, so example 2. Example 2 here, x squared plus 6x plus 5. So again, we're going to write this as multiplication of two polynomials. You're going to look at this 5, right? How else can we write 5? 5 times, or what times what will equal 5? Think about it for a sec. Because 5 is a prime number, the only possible product is 5 times 1, right? So that means a 5 has to go here and a 1 has to go here. We know it's not subtraction because 1 plus 5 equals 6, right? So if we had plus 4x plus 5, we would have something and x plus something else. Again, 5 can only be product of 5 and 1, right? But we have a 4 here, which means I would have a positive 5 and a negative 1, because 5 plus a negative 1 will give us 4. So that's how we do those. There are some more examples, but they look pretty similar to what I've been doing. So if you need more help on those, look through the examples, and if those are not helping you, then go ahead and send me a message in chat, and I will walk through another one of these examples.